viewers, today we determine some interesting results of inverse Laplace transformations, inverse Laplace transform and how to use it. And basically this problem is based on the differentiation of Laplace transform. Now let us consider an example at first. Let L inverse of ln s square plus 1 by s plus 1. We use here the parameter s instead of parameter t. Whatever may be the same cases. We may use the parameter s instead of t. Now here it is Laplace transform of s square plus 1 by s plus 1. Now let gt equals to this. And this will be equals to L inverse of gs. So it should be noted that the formula of L inverse gns, that will be minus 1 whole to the power n tn L inverse of gs, which we discussed in the earlier videos. If we take n equals to 1, we get minus of this result. Now clear, for g dash s we are taking differentiation here and use the property of logarithm. Log of ln of s square plus 1 by s plus 1 equals to ln of s square plus 1 minus ln of s plus 1. After differentiation we get this result, and using the linearity property here, and it's clear it will be the result of cos t, which we discussed in the earlier classes, and using here shifting theorem, so e to the power minus t L inverse of 1 by s. Now it's clear it will be 1, so we get this result. So finally we get from the result L inverse of gs, so minus t will be divided by this result, so my final answer will be minus 2 by s cos t plus 1 by t e to the power minus t, and we put the result of gs of this. So finally we get L inverse of ln s square plus 1 by s plus 1 equals to minus 2 by t cos t plus 1 by t e to the power minus t. This will be the final answer. Now let us consider another examples. L inverse of tan inverse 9 by s. Let similarly gt is equal to this. So using the same formula, minus t of this equals to this. Here gs is the parameter. So minus L inverse of, taking differentiation of this term, simply differentiation of calculus, for 1 by 1 plus x square tan inverse x, differentiation of tan inverse x is equal to 1 by 1 plus x square. Using this formula, that will be 1 by 81 by s square, and taking differentiation of this term, minus 9 by s square. So it will be L inverse of minus 9 by s square plus 81. Now it will be clear minus of sine 90. That will be 9 square, that's why sine minus of sine 90. And so formula of L inverse sine alpha t equals to alpha, that will be Laplace transform of sine alpha t, that will be alpha by s square plus alpha square. So it will be 9 square, so that will be in the 9 in upper, so minus of sine 90 is there. Now so clear from the earlier result, we dividing both side by minus t, that will be we get L inverse of gs equals to minus minus will be cancelled, that is 1 by t sine of 90. So final answer will be L inverse of tan inverse 9 by s will be 1 by t sine 90. So in this way we can easily evaluate many kind of Laplace transform, inverse Laplace transform for the specific of this type of problem. So today we end our classes. Thank you.